Good evening, friends. I'm coming with successive differentiation. Other name is higher derivatives. And the still other name is तारीख पे तारीख. Successive means एक बार डेरिवेटिव लेंगे फिर उसका डेरिवेटिव. No, here I'm explaining it. If y is equal to fx is differentiable with respect to x, then its derivative dy by dx can be found with respect to x, which is known as the first derivative. ठीक है, एक बार डेरिवेटिव ले लिया. If the first derivative is also a function, first derivative is called dy by dx, is also differentiable function, then it can be further differentiated with respect to x, and the derivative will come as d2y over dx square. That is the second derivative, which is the second derivative of y with respect to x. And if second derivative is also differentiable, then its derivative will be called the third derivative of y with respect to x, which is denoted with d3y over dx3. देखिए, पहले एक तारीख लगी, एक डेरिवेटिव हो गया, फिर डेरिवेटिव का डेरिवेटिव हो गया d2y dx स्क्वायर बन गया, फिर उसका डेरिवेटिव हो गया d3y. सो सक्सेसिव differentiation is going on, or तारीख पे तारीख. Now let us go further. Look here, symbol of second derivative. It can be written like this: d2y dx square, or y2, or y double dash, or capital D square y, or f double dash x. Second derivative means तारीख पे तारीख. Now let us learn with fun. So I'll be taking up few examples, and you will find that they are very, very easy. If y is equal to sine inverse x, show that y2 is equal to x over 1 minus x square raised to power 3 by 2. Let us see. Y is equal to sine inverse x. Let us take the first derivative. ddx of left side is equal to ddx of right side. That is, ddx of y is equal to ddx of sine inverse x. So this can be written as y1, and sine inverse x का डेरिवेटिव होता है 1 over अंडर रूट 1 minus x square. Let us take second derivative, because we are interested to find the second derivative. Derivative का derivative. So ddx of y1, ddx is derivative of the first derivative, it becomes second derivative. So when we will take this derivative, what we will get, it will be x over 1 minus x square raised to power 3 by 2. On solving this, we get this. Let us go to example number 2. Y is equal to 10x. Prove that y2 is equal to 2y1. Now, solution is this way. Y is equal to 10x. Let us differentiate both sides. Y का derivative y1, 10x का derivative secant square. Let us again differentiate. y1 का derivative y2, it is ddx of y1, it will be y2. secant square का derivative 2 नीचे उतरेगा, एक पावर कम हो जाएगी, secant का derivative secant tangent, it becomes 2 tangent secant square, and this is ddx of y1, that is y2. So y2 is equal to 2y1. This is what we wanted to prove. Very simple, very simple. Now let us go to example number 3. If e raised to power y within the bracket is x plus 1 is equal to 1, we have to show that y2 is equal to y1 square. Now let us take the y term on one side and x term on other side. So take this x plus 1 to the right side. it becomes e raised to power y is equal to 1 over x plus 1. Now let us take log of both sides. So it will be log e raised to power y, left side is e raised to power y, it will be log 1 over x plus 1. So y नीचे उतरेगा, it will become y log e, and log is 1. Log is 1. So it is y into 1, it is y. Y is equal to, this is log of 1 is 0, it is 0, minus log of x plus 1. Log m by n, I have applied log m by n. Log m means log 1, that is 0, minus log n, that is log x plus 1. Let us take further derivative. This is y, its derivative is y1. Okay? Now it will become minus log fire, 1 over fire. फायर का डेरिवेटिव 1 होगा, इसलिए 1 लगाया नहीं है. इट इज़ माइनस 1 ओवर एक्स प्लस 1. लेट अस टेक सेकेंड डेरिवेटिव. 1 ओवर एक्स का डेरिवेटिव होता है 1 ओवर एक्स स्क्वायर विद माइनस, और यहाँ पे देखिए ऑलरेडी माइनस है, माइनस माइनस प्लस, सो इट विल बी 1 ओवर एक्स प्लस 1 स्क्वायर. सो दैट इज़ 1 ओवर एक्स प्लस 1. 1 over x plus 1 is your y1. y1 is your this. So it will become y2 is equal to, y1 is your 1 over x plus 1. Put it here, it is 1 y1 square. So y2 is equal to y1 square. So now there are general formulas, nth derivatives. अब मान लीजिए डेरिवेटिव लेना है n टाइम्स, सो इट विल बी कॉल्ड nth डेरिवेटिव of some standard functions. These functions which we will be discussing, they are all standard. Now let us take first one. dn over dxn is called nth derivative of sine ax plus b. Sine is a standard function. Now it is equal to a raised to power n sine n pi by 2 plus ax plus b. Supposing we take n equal to 1, it will become d1 over dx1, that is ddx of sine ax plus b will be sine a raised to power 1 a into sine pi by 2 plus ax plus b. Sine pi by 2 plus this is cos, it will become cos ax plus b. देखिए साइन ए एक्स प्लस बी का डेरिवेटिव होता है कॉस ए प्लस बी. दिस हैज़ बिकम कॉस ए प्लस बी बिकॉज इट इज़ साइन 90 प्लस थीटा, दैट इज कॉस थीटा. सो इनटू ए एक्स प्लस बी का डेरिवेटिव ए, दिस इज ए, एन की जगह 1 लगाना है. सिमिलरली nth डेरिवेटिव ऑफ कॉस ए एक्स प्लस बी इज जस्ट सिमिलर. इट इज़ ए रेज़्ड टू पावर n, इट इज़ कॉस n पाई बाई 2 प्लस ए एक्स प्लस बी. Now, nth derivative of ax plus b raised to power m, it is equal to m factorial over m minus n factorial a raised to power n ax plus b raised to power m minus n. Nth derivative of log ax plus b, it is minus 1 raised to power n minus 1 factorial a raised to power n over ax plus b raised to power n. Let us go to the fifth one. Nth derivative of e raised to power ax, it is a raised to power n e raised to power ax. देखिए a raised to power n सब में आ रहा है. जब भी nth डेरिवेटिव लेंगे a raised to power n साथ में लगेगा. It is e raised to power x. Now let us go to this. Nth derivative of a raised to power x, it is a raised to power x log a raised to power n. देखिए n की जगह 1 लगाइए. ddx of a raised to power x, it is a raised to power x log a. फिर सेकंड डेरिवेटिव लेंगे, log a की पावर बढ़ती जाएगी, a की पावर x का डेरिवेटिव a की पावर x रहेगा, साथ में log a बढ़ता जाएगा, उसकी पावर बढ़ती जाएगी, n टाइम्स करेंगे पावर n हो जाएगी. दिस इज व्हाट वी wanted to have today. They are the successive derivative. Look here, derivative of y is y1, y1 का डेरिवेटिव y2, y2 का डेरिवेटिव y3. दिस इज कॉल्ड तारीख पे तारीख. So this is what I wanted to teach you today. So with this, I'm closing this, and there are few questions left on exercise 5.7 that I'll be taking up in my next video. Thank you very much. Keep on watching my videos. Share it among your friends. If you like it, please do subscribe it. Thank you. God bless you. Good night.